we are asked to find the limit.
Simplify.
Not something like, but you're right. Yes, I have to say,
The domain.
no. Every time we look at a limit.
Plug in?
Yes, exactly. So we want to plug in. So basically, you have to plug in infinity. Look at the top. Which of these three terms is the most powerful?
The
3x cubed.
Right, these are too small. Look at the bottom, and which of these three terms is the most powerful?
4x cubed.
So forget about those. So the numerator goes where?
It's in the positive direction.
When x approaches infinity, the numerator goes to?
Infinity.
Perfect.
Infinity.
Right, and the denominator also goes to infinity. So this is our situation. How do we call infinity divided by infinity?
It's undefined, right?
Nope.
It doesn't exist.
Nope.
One?
I wish.
Isn't it intermediate or something?
Indeterminate case. How many indeterminate cases we said there were?
7.
So this is the total. So this is an indeterminate case. Which other indeterminate case we've seen so far? Many times. Thank you very much. So we have seen 2 indeterminate cases so far. Infinity over the infinity and 0 over 0. Great job. In the next chapter, we are going to learn, because I'm not going to wait till chapter 4, we're going to learn a very easy process for this. Either infinity over infinity or 0 over 0, but we don't know that yet. Good. So we don't have a way of immediately determining the limit in these two situations yet. So bear with me. So you already told me, but not in those words, what is the degree of the top?
3.
Good. So from here, you know me, I'm lazy. I will circle that and continue here. I will not drop the limit operator till the very last step, please. Okay. I will factor out the numerator. I will factor out the degree because you told me it was 3. And now tell me what you write in parentheses. What is left in parentheses when I factor out x cubed? And if you say, but wait a minute, x cubed is not a common factor, I will have to agree. It's not. I will force an x cubed out. As long as whatever I write here works. X cubed times this is 3x cubed. X cubed times this is negative 8x. And x cubed times this is 2. I'm fine. Even if x cubed is not a common factor. So what goes in there?
Would it be 3
Yes.
minus 8 root x? No, 8 square root x, my bad. 8 over root x?
8 plus 2?
8 over x?
8 over x squared.
Very good. Plus? Plus?
2 over x cubed.
Good. Everyone with me? Everyone understands this?
I'm a little confused.
You shouldn't, but I'm kidding. X cubed times 3, 3x cubed. X cubed simplified with x squared, I get 8x. X cubed simplified here, I get 2. Is that okay?
Okay.
Because you're just essentially multiplying each one of those individually and rebuilding it, right?
I can always do that. So even from A, I can factor out x cubed. Even from -2, I can factor out x cubed. I can factor out x cubed from anything I want. So the denominator is also, the degree is x cubed. Can anyone give us the inside?
It's going to be 4 minus 5 over x plus
I'm sorry, I meant to write minus. I'm going to delete that. -2 over.
x cubed.
Very good. So don't be afraid. You can factor out as long as it serves a purpose. You can factor out anything you want from anything you want. X cubed times 4 is that. X cubed times -5x is -5x squared. And x cubed times -2x cubed is -2. We didn't change anything. Okay, now what do you think I'm going to do next? You don't know much about me, but I know you know what I'm going to do next. I know that.
You're going to cancel out the x cubed.
Of course. Of course. Of course. So then I have limit. I do not drop the limit operator. It's not ready to go away. I'm going to copy it one more time so I can explain it. Although you could have just written the final answer at this step. But I just want to show what I'm doing. And I don't have enough space there. Okay. So here's the next step. At this point, I'm going to ask you, where does this go? Where does this go? Where does this go? And where does this go when x approaches infinity?
0.
In case you're wondering why, it's because when x approaches infinity, any number, I don't care, over x to any power approaches 0. As long as the power is positive. The power has to be positive. Good, so then now I can drop the limit operator because I'm applying it. And the final answer is
3/4.
Thank you very much, which means
That's a horizontal asymptote.
y equals 3/4 horizontal asymptote. Since it's a rational function, it will be on both sides. It doesn't matter. If I write this, the answer will still be the same. If this goes to negative infinity or positive infinity, the answer is still 0. So it won't make any difference because it's a rational function. Very good. Any questions on this? As you've noticed, I work on with you on these problems with a speed of the moonwalk, just to make sure that everyone follows and everyone can ask questions. It's really moonwalk.
What are the other 5 indeterminate cases?
Oh, well, we're gonna list them when we get to them.
Okay.
Yes, we're gonna get to them in L'Hopital's rule in chapter 4. All of them. Okay, so back to, so we looked at rationals. Okay. Here is an interesting situation in number 26. Here is another indeterminate case, a third one that we are going to be able to look at, or this one. And we should look at e to the x. There are so many different, and also arctangent. There are so many different ones. So many different.
You start with 26 then.
So let's take a look at 26. Perfect. So in 26, we have limit as x approaches negative infinity. from the square root of 1 plus 4x to the sixth over 2 minus x cubed. Okay, back here. Before we continue, let's refresh our memory again on the absolute value of x. And you can say, absolute value of x, what are you talking about? Where do you see absolute value of x? In a moment, you will understand what I'm trying to say and why. So can anyone give us a definition of the absolute value? Yan, will you give us the definition?
The definition of absolute value,
Please, yes.
it's the distance from zero.
Formal definition. The formal
Okay,
definition.
and I did the same thing.
Formal
Okay.
definition.
What the formal definition would be.
I'm sorry?
I'm not sure what the formal definition would be.
Okay, we used it several times. Okay, Nabiha?
It's x if x is greater than or equal to 0, and negative x if x is less than 0.
Brilliant, thank you very much. So here's another question. So this is number 1. Please remember, maybe it's my mistake. Remember. It's my mistake. I probably forgot to say remember, but you have to remember it. Here's number 2. When I take the square root from x squared, what do I get?
X.
You have to value that.
Thank you
Or no,
very
plus minus x.
Thank you very much. This is crucial to understand. So the problem with the square root is this quantity is always positive. Therefore, this quantity has to always be positive. Where does this come from? It comes from solving such an equation when we take the square root. If we write x equals 2, that's incorrect. So I have to write plus or minus 2. And I hear my students sometimes say, oh, yes, of course, because the square root of 4 equals plus or minus 2. No. No. The square root of 4 does not equal plus or minus 2. No. The plus or minus come from this side because the square root of x squared is the absolute value of x. So there is an intermediate step here, the absolute value of x equals 2, that changes into this. It's a quadratic equation. I have to get 2 solutions. So again, let me write here so I don't forget. Remember, the square root of x squared is the absolute value of x if x can be anything. Now, if you tell me that x is greater than or equal to 0, when I take the square root of x squared, then I have to write x. But if you tell me that x can be anything, for x, and this is the way we represent all real numbers. So if x can be anything, that it needs absolute value on it. So it guarantees it's always positive. So these 2 concepts I need for this limit. And you'll see how and why. Okay. Okay, I'm going to write the limit from scratch. So the limit as x approaches negative infinity from the square root 2 minus x cubed 1 plus 4x to the sixth. Okay, you know me a little bit. What do you think I'm going to do first? Trey, what do you think?
Apply infinity to the equation.
Say it again.
Apply infinity to the equation. Or negative infinity.
You have to plug it in, right? You have to plug it in to see what's going on. But I don't like the way that this is twisted. So I'm going to rewrite it as limit as x approaches negative infinity, the square root of 1 plus 4x to the sixth divided by x cubed minus 2. Yes, I should have replaced this and put it in the correct order as well. And now we plug it in. So where does the numerator go when x approaches negative infinity? Not Jordan, but Jordan. Are you with us? I haven't heard your voice today. Jordan, are you with us?
Me?
No.
Can you hear me?
Yes, I can now. Are you
Sorry, I
okay?
was muted.
Yes, I know. Sorry.
Would it be infinity?
Very good. Indeed, infinity. Where does the denominator go? Miki?
It goes to positive infinity.
It's still negative infinity, but we don't care. Infinity over infinity is still the same thing. Plus or minus, we don't care. It doesn't matter. Very good. So how do we call infinity over infinity? Gabriel?
It was indeterminate.
Very good. Awesome. It's one of the indeterminate cases, and we know two so far. 0 over 0, we've seen these two so far. We're going to see the third one very soon. Perfect. So our next step is identical with what we covered before. The first step. What is the degree inside?
Degree 6.
Yes. So I will pull out x to the 6th. Can anyone give us what is left in parentheses? Gia, will you want to give it a shot?
Would it be, hold on 1 second. Would be 4 over, so I'm starting out with the leading code.
It's fine. So you have 4. Very good. Awesome. That's what we should have been. 4 plus.
Plus 1 over x to the 6th.
Great job. Excellent. What about the denominator? Anyone? Brilliant. Thank you. Kush, will you give us the denominator? What is the degree of the denominator?
So x3.
Good. So what is the degree then if you said x to the 3rd?
It's gonna be minus.
So the degree is to x to the 3rd. Lindsay, what do I write inside?
Would that be 1 minus 2 over x to the 3rd?
Brilliant. Excellent. Great job. Okay. Next step. Keep the denominator as is. We have the square root of a product. So another reminder, reminder number 3. The square root of a plus b does not equal the square root of a plus the square root of b, or minus. No. But the square root of ab, if they are real numbers, okay, can be written as the square root of a times the square root of b. So then we have to take the square root from the first quantity and the square root from the second factor. First factor, second factor. So this is limit. X approaches negative infinity. The square root of x to the 6th times the square root of 4 plus 1 over x to the 6th. Everything divided by x to the 3rd, in parentheses, 1 minus 2, x to the 3rd. Any questions so far?